We'll go back and go over how to differentiate e to the x and ln x in a later lesson. For now, we're going to move on to the chain rule, one of the most powerful differentiation rules, and guarantee you'll have to do this on both versions of the AP exam. The chain rule helps us find derivatives of the composition of functions. Let's review what those are real quick. F composed with g means we apply f to the output of g. Let's call g the inner function and f the outer function. Consider the following function. We can write the square root of sine of x as the composition of two functions. Sine of x is the inner function, which I'll label u. The square root function is the outer function. Pause the video and identify the inner and outer functions for the following. Now let's talk about finding the derivative of composite functions. Consider this composite set of gears. Notice the three axles, y, u, and x. As axle y revolves, it turns gear 1, which in turn turns gear 2, causing axle u to revolve. We can express the rate of revolution between these two axles as dy du. As axle u revolves, it also turns gear 3, which in turn turns gear 4, causing axle x to revolve. We can express the rate of revolution between these two axles as du dx. Combining these two, we can get dy dx, that is, the rate of change of the first axle, y, with respect to the third axle, x. dy dx is the product of the rate of change of y with respect to u and the rate of change of u with respect to x. This is called the chain rule. The chain rule says if we have two differentiable functions, then the derivative of the composition is equal to the derivative of the outer function evaluated on the inner function. That means you leave the inner function alone, times the derivative of the inner function. We can write this in Leibniz notation by writing g of x as u and f of u as y. Then y can be written as f of g of x and is differentiable with respect to x. Du dx is another way of writing g prime of x. Dy du is another way of writing f prime of u. In other words, f prime of g of x. Finally, dy dx means we're taking the derivative of f composed with g. And we get the same thing we had earlier. Here's two more ways to write the chain rule. Now let's use the chain rule to find the derivative of the square root of sine of x. First, let's rewrite. Then take the derivative of the outer function evaluated on the inner function. Recognize the inner function is sine of x. Following the power rule, finally multiply by the derivative of the inner function. The derivative of sine is cosine. Try this one. Find the derivative of this composite function. For this function, you can consider the inner function to be x squared plus 1. By the chain rule, you get which simplifies to. Let's do one more. Find the derivative of this function. This time let u be 3x minus 2x squared. Apply the power rule to get the derivative of the outer function. Times the derivative of the inner function.